Hi class, this is Dr. Martino. This is PV Loop video number 4. If you have not watched the first 3, I would recommend that you watch these in order. Number 4 is going to focus on something called the inotropic effect. Again, we're still in the left ventricle. Think of the fight or flight or freeze response or exercise. Let's define an inotrope. An inotrope is a substance which either increases or decreases the energy usage or the contractility of the heart. And the contractility of the heart is the derivative, the slope of the amount of force produced over time. So you're going to produce more force over less time. There are positive and negative inotropes. Positive inotropes increase force production, contractility. Negative inotropes decrease it. So positive inotropes are digoxin and digitalis, berberin, calcium, calcium sensitizers such as levosimendan, catecholamines such as norepinephrine, epinephrine, dopamine, angiotensin II, which is a vasoconstrictor, eicosanoids such as prostaglandins, phosphodiesterase inhibitors such as Viagra and Cialis, glucagon and insulin, all positive inotropes. Negative inotropes, beta blockers, non-dihydropyridine, calcium blockers, and antiarrhythmics such as quinidine and procainamide. Those are class 1As, and class 1Cs are flecamide. So what are we going to do today? So we start off with a normal curve for a normal healthy heart. As always, we're going to begin at this corner here. Now the diastolic curve, I didn't mention this specifically, but can move up or down. I did mention that part, but I didn't mention what would make it move up or down. If you have a situation where the heart is becoming more and more flaccid, right? It's being weakened, and congestive heart failure can do this, then this would shift down, and that would be the effect. If the heart was starting to stiffen through some other kind of disease, then the curve would start to move up. Most of the time, we're not dealing with that kind of pathology, so the diastolic curve usually stays the same. So the next question you ask yourself is, are you increasing, or decreasing preload? Well, when you get a positive inotrope, let's think of fight or flight, right? You have a lot of epinephrine and norepinephrine being released. First, let's start with the right side of the circulation, the venous side. And the venous side of the circulation has the same receptors, alpha and beta adrenergic receptors, as the arteries do. So on the venous side, which is the storage side of the blood, you can think of the venous side of the blood as a storehouse for blood. Those vessels start to constrict. And as they constrict, you get something called an increase in venous return back to the heart. So more blood comes back to the heart. That ultimately increases the preload, the amount of blood that's in the left chamber of the heart. So what starts to happen? More and more blood comes back to the left ventricle, and you get something like this. Okay. So next, you start to ask yourself, well, what happens during isovolumic contraction? Well, you got to start asking yourself, what happens to the aortic valve opening? What determines when a valve opens? The pressure on the outgoing side. What's the pressure on the outgoing side of this valve? It's arterial pressure or aortic pressure, right? So what's happening simultaneously as the veins are starting to constrict, right? Epinephrine's going everywhere, then the arteries are starting to constrict. When the arteries constrict, right, they increase the resistance to blood flow. The increase to resistance to blood flow is because of increased friction, right? The vessels are just smaller in diameter. Their radius is smaller. What does that do? It increases the blood pressure. So now your diastolic pressure, when this is all happening, is going to go up from 80. So let's just pick a number like 100. So now you're going to go all the way up to 100. That means that that's the point at where the point that you have to exceed in order for the aortic valve to open. So you got to get to 101. Okay, so that happens and you get an ejection. You get an ejection, right? So you're going to get a greater ejection, right? Because the contractility of the heart is increased. So now you got to ask yourself, does anything move this systolic curve? Well, in a healthy heart with an inotropic effect, the systolic curve will actually move out to the left. It'll move to the left. So what you will have happen is not only will you get a greater peak, right? And you've got to come back all the way to the curve here. And then you drop a line. So what's happened here? You have a bigger PV loop from the inotropic effect. You had more blood coming back to the left side of the heart, which increased the preload. Increasing the preload invokes the Frank-Starling law of the heart, which says that you now have a greater overlap of mactin and myosin. You're moving up on the curve, a different curve, where the resting length of the heart and the optimal length are getting closer together. So that will force all of this extra blood that came in out. Okay. Then you get a peak contraction that's going to be greater, one, because of the Frank-Starling law of the heart, and two, because of increased contractility. Okay. The heart has gotten stronger. So what ends up happening is you will ultimately end up having less blood sitting in the heart at the beginning of the next contraction, right? So this blood you got rid of because it came in because of the Frank-Starling law of the heart. This increased peak here and decreased blood in the heart are due to the contractility, right? And the increased peak is also due to the Frank-Starling. So this part over here has to do with increased contractility and the Frank-Starling law of the heart. This part here has to do with the increased contractility. So if you take a look, the original amount of work that you had done was this, right? It's the area under the curve. But the work that you did now, or you do now, when you have an inotropic effect, is under this curve. Okay, so you made the heart stronger. So that's what happens when you exercise. Now, if you have a negative inotrope that was added to your system, then the reverse of all of this would happen. You'd have less blood in the chamber. You would have a lower pressure here, so the aortic valve would open up at a lower pressure. You'd get a lower peak, and you would have essentially more blood in the chamber at the end of the contraction, so you'd have done less work. There's an infinite number of examples I could give you, but that's the basic gist of the inotropic effect. I hope this makes sense. And again, if this is confusing, go back and read, listen to the full lecture, and please listen to the first 3 mini lectures in PV loops. We will have 2 more mini lectures in PV loops. The next one will deal with congestive heart failure, and then the final one will deal with a PV loop for the right side of the heart. I hope you had fun. I hope you learned a lot. Have a great day.